Hi, welcome back. So we're going to be talking about prime numbers in this unit, Unit 1.3. We have talked about this previously in Unit 1.1, but today we're just going in for more details. So just a quick recap on things. Prime numbers are integers with exactly two factors, which is 1 and itself. Composite numbers are the opposite to prime numbers, so they have more than two factors. 1 is neither a prime number or composite because it has only one factor. And some of the prime numbers that are below 100 is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 87. You don't have to memorize any of this, but it is really good to actually be familiar with some of the examples that are less than 100. So the new thing that we're going to learn today is prime factors, which are factors of a number that are also prime numbers, right? Previously, in the previous video, we have learned about factors. So those factors, now you introduce a new condition, which is factors that are only prime. So because prime factors have only two factors, so meaning to say every non-prime number, which is every composite whole number, can be broken down and written as a product of its prime factors, right? There's two methods to do this. We're going to go through both of them. One is long division and the other one is called a tree diagram. For an example, we're going to do this exercise. We're going to write the following numbers as a product of prime factors. A is 36 and B is 48. We're going to try both of the methods for long division and tree diagram, and you can look at which one suits you better, both of which would give you the same answer anyways. To write 36 as the product of prime factors using the long division method, first things first, we're just going to write 36 in the beginning, and we're just going to start dividing it by only prime numbers. So 2 is a prime number. We can divide 36 by 2. We're going to get 18. And then we're just going to repeat this process until we reach 1. So 18 divided by 2. Again, 2 is a prime number. We get 9. 9 cannot be divided by 2. So we're going to use 9 divided by 3. Right? 3 is the next best prime number that we can divide this by. So 9 divided by 3, we get 3. 3 divided by 3, we get 1. Once you reach 1, you cannot divide it by any other prime numbers anymore. Then that is where you're going to stop. And then you're going to take all of the numbers on the side here. 2, 2, and 3, and 3. So we're going to multiply all of them. 2 times 2 times 3 times 3. This is 36, right? You will find back the original number, but this is what we want anyways, because now we have written 36 as the product of all the prime factors possible. So 2 times 2 times 3 times 3. Okay, now we're going to look at the other method, which is on the tree diagram, but we're going to do the same thing. We're going to write 36 in the beginning, but this time we're just going to branch it out into two sides. So these two sides can be any factor. So I'm just going to write 3 and 12 because 3 and 12 multiplies to 36. Okay, if you look at these two branches, one of them is a prime number, one of them is not. When you see this kind of situation, you want to put the prime number on hold. And for the non-prime number, you're going to continue splitting into two branches again, which must be factors of the original number. So in this case, I'm going to write 3 and 4 because 3 times 4 makes 12. Again, I see that the prime number 3 is there and I'm going to put it on hold and I'm going to continue branching from 4. At 4, I'm going to branch out into 2 times 2, and over here, I already get 2 prime numbers, right? These 2 prime numbers, I cannot continue splitting, so it means this is where I will be stopping. So all of the prime numbers that we have held from the very beginning until now, we're going to put them again into a product chain. Meaning to say, we're going to put 2 times 2 times 3 times 3. All 4 of these numbers are the product of prime factors of 36. So, okay, the next example, we're going to look at 48. We're going to try both of the methods again, and I'm going to show you the working, I'm going to show you the solution. If you're able to find it, then you pretty much know how to find the prime factors of any other number now. Okay, so these are the solutions and these are the working, and you can cross-check whether you get the correct answers or not. So just bear in mind that both of these methods will give you the same results, right? You just have to pick whichever that feels best for yourself, and you will continue using that until you don't need to use them anymore. And that is it for the prime numbers. Until this section, we're going to have a part 2 to look at some of the exercises and as well as finding your HCF and LCM using this prime product methods. I prefer using long division, but it's all okay if you prefer the tree diagram, whichever that works for you. Right? I'll see you in the next video. For any further inquiries or questions, check the description or put it in the comment below. And I see you in the next video. Bye.